And now let's talk about InnoDB metrics. So what to look for regarding InnoDB and CPU? Well, I mean, the overall CPU utilization is something which we actually can derive a couple of informations from. Because, for example, let's say that we have a 100% of the CPU utilization. Well, obviously, maybe it's time to scale up a cluster. But also it may mean that there are some queries to be tuned, and obviously, I mean, or maybe something happened like a query execution plan that I mentioned before that caused the query to be more expensive and more CPU bound, for example. Let's say that the CPU utilization is low, but the queries which should be fast are slower. Then this could be this could be caused by some locking contention, like row level locking, maybe auto increment lock contention, something like this. Maybe there are some long-running transactions that are locking a bunch of rows and slows down the other writes, for example, inserts or updates that otherwise would be almost instant. So this is something. In this case, we should be looking into process lists, into InnoDB details about the row level locking. What about the high CPU utilization, but not 100%? Let's say 75, 80%, and still the slow queries. Well, in this case, this could be something that would lead us to the point that there may be internal contention within InnoDB, like MUTEX contention, something like that. And therefore, under your particular workload, basically InnoDB can't utilize fully the potential of the hardware that is below that your server is using. And it's maybe. And if the significant part of this of the CPU utilization is the system part, well, this is even a stronger suggestion that there may be some problems within InnoDB, because it may mean that InnoDB is running a bunch of OS wait calls, which are system calls, and they are therefore accounted for the system CPU utilization, and they are somewhat a last resort for InnoDB to sort the contention, the internal contention within. So it may mean that there's definitely something to look at and see how we can, what data we have to debug the internal contention. Well, for a Percona server and MariaDB, there are status counters that are available, and we can take a look at them. There is show engine InnoDB status command, which gives us the nice status of the overall state of InnoDB. And among others, the internal contention. There's show in the InnoDB MUTEX command, which gives us the list of the weights in the system. And then there's a performance schema. In 5.6, performance schema is by default enabled. But to have the MUTEX weight instrumentation enabled, you have to restart MySQL, because by default it is disabled because of the additional overhead that it provides. So show engine InnoDB status. Well, this is a list of the current weights. So you have to keep in mind that it's may not always represent the average state of the weights in your cluster. You're just looking at the thing that happened when you type enter. And the semaphore sections, that is the example you can see on the left side. It's not always there. I mean, if there's no contention, then you won't see this particular section here. As you can see, the information points you to the source code, which is kind of okay, because I mean, you don't have to be proficient in C, nor you have to know the MySQL source code by heart to benefit from it. Actually, it's really sometimes it's really enough to go to the file, go to the line, see the comments around this place, see the function and the comments regarding of the function where this line is located, and it tends to give you a nice insight of what kind of operations were causing the problem, and it may give you some additional awareness about what kind of issue you are facing. In cluster control, engine InnoDB status is available in the performance and engine InnoDB and InnoDB status tab. So it's pretty easy to check, and it also consists a nice material for further googling, because it's a plain text. You can copy paste it. You can feed Google with some of the data from here. And if this is, let's say, popular problem, if it's common problem, then you may find some information about either maybe a bug reports, or maybe some suggestions how to fix go around it, or maybe information in which MySQL version the bug was fixed. So pretty useful data you can derive from this bit. Show engine InnoDB MUTEX. So this command gives you a list of most common weights in server stat. It's not unfortunately it's not flashable, so you have to work more on the deltas than the actual values. And on the left side, you can see the top 10 weights in my cluster under the sysbench workload. And as you can see, the BTR search large array is pretty high on the list. So it just points me to the direction of InnoDB hash index, InnoDB adaptive hash index. Maybe I should add some arrays to it, or maybe I should try to disable it and see if it helps in my particular workload. In performance schema, and I'm talking about 5.6 performance schema, you can get similar data by running this nice query. But in general, performance schema gives you a really nice overview of the system status. You have the SQL to do some magic like aggregates or do anything you may want to. Again, if you take a look at the results, the BTR search large is on the top. So yeah, definitely there is some contention here that I should be looking at. And then we have and then you can install a schema from Marklate that gives you even better visibility for into what's going on. So InnoDB I/O metrics, why they are so important? Well, the Galera runs on InnoDB. So if InnoDB is not happy, then Galera won't be happy too. You need to know your I/O to configure InnoDB correctly, because some tuning depends on the type of the I/O workload that you are doing. You also need to know your I/O to pick a right hardware, because InnoDB does different type of I/O. Some of it is sequential, some of it is random. So if you are considering, let's say some spindles still in the configuration, or you have a server with mixed spindles and SSDs, then you may want to then you probably want to know a little bit about what kind of I/O your InnoDB is doing the most popular type of traffic. And obviously, yeah, the I/O, when it's getting out of control, it will result in unstable MySQL performance. It is because then when there is the buffer pool is filled with modified pages, or the redo logs are filled with data, then MySQL will switch its priorities from serving the queries to actually flushing this data to disk and freeing some resources here. And therefore, it may result in spiky performance, on average, or even lower throughput, and less stable. So we want to take a look at this particular data, particular metrics. So what to monitor? Obviously, reads, writes, fsyncs. This is those operations are pretty important. We want to monitor the status of buffer pool dirty pages. These are the pages which were modified in the buffer pool, but not yet, but hasn't been yet flushed to disk. And we want to monitor checkpoint age, which is basically the information about how many data InnoDB has in redo logs, and which are not flushed yet to table spaces. And InnoDB flushing, so how InnoDB, what kind of flushing InnoDB does.